Hello everyone, welcome. It's a time for class again. This is ECE341, the probability and random process class. Last time we introduced some axioms and theorems about the probability. Today we will study some examples where we can apply those axioms and theorems to calculate some values of the probability. Okay. It's ECE341. This is the second week Friday's class. Okay, it's Friday again. The time goes fast. Actually, today is the last day of the first 2 weeks. It's the last day for you guys can change your courses if you want to take some different course, you want to make some change. Today is the last day. Alright, just remind. Okay. Example. Example 1 is here. I typed it in a file. So we consider score of a student. That will be a point between 0 to 100, and as normally we have A, B, C, D, and F, different letters. Now suppose this student, the past scores show half of the scores are between 81 to 100 and equal likely. So that means this guy, his score between 81 to 100 ending point will be samely possible, right? Same possibility, same probability. And another half of the score are between 51 to 80 and also equal likely. And the score of 50 or less never occurs. So we can just suppose this kind of rate or distribution of the possibility as his probability, and then we try to determine the following probabilities, right? We have 1, 2, 3, 4, 5, 6, 7. So how to work on these kind of things? So first step, we need to try to understand the two things. One is the sample space. Second is the distribution of the probability to those samples. And then we can find the probability. Alright. So here we start from the we try to solve step 1. We try to determine the sample space. Here the sample space we can consider it is just the S from 51 S50 until S100, right? So we suppose the he never gets scores of 50 or less, and we just suppose this time he will not have the same low scores again. So always over 50. So the sample space will be start from score 51 until 100. So here totally you can check the amount of the sample space. Okay, it's S. I use a capital S denote the sample space. Then this one contains how many numbers? Totally 50, right? We have 50 numbers in the sample space. And then we have the sample space. Secondly, we check what do we have for the probability. We know the probability for Si. Alright, in this way. This is a set contain Si. Then the probability, it will be equal to each other, equal to some number A if I run from 51 to 100 and Si were equal to another number, constant number, if I run from, oh no, this is 81, from 81 to 100, right? 81 to 100 is equal likely, and from I to 51 to 80 is also equal likely. So they have same number, and these have another same number, and we know these are half. This is another half, right? Half scores between 81 to 100, and another half scores between 81 to 80. So I will say the totally should be 100%, right? Totally 100%. So okay, so this is a amount is 81 to 100. I have 20, and this is amount is 30. So we have 20 of A plus 30 of B. There will be 1, right? Why we can have these? We have axiom. The probability of the whole sample space, there will be 1, right? That's it. You have this one. Then you put all of it. You do summation of all of these. You will have 1. Okay. And we also know what we know half and half, right? So this is half, another half. So 20 times A equal to 30 times B. They are half. Both are half. Alright. Okay. Now we have two equations. Two equations with two unknowns. Then we can know what are these A and B. What are these A and B? Can we have it? Okay, so this half, oh, well, I don't need this. Actually, I need this, so I'll be fine. Half and half. So A is 0.5 over 20. How to say? Is half times 2 or half divided by 20. So this is 1 out of 40. And the B is also half, but here is 30. Right, 30B is half, so this is half times 1 over 30, which is 1 out of 60. Okay, we have A and B. So if score in the A, the probability will be 140, and the score is in the B case, it will be 1 over 60 as a probability. Okay, so now it is clear. We know all these probabilities for each sample in the sample space, right? You all know, okay, for this model, we know what is sample space, and we also know what is the distribution of those 100% to each samples. Okay, now we can turn to our result. We go to step 3, find the answers. Find the answers. So the first one, what is the probability of the sample 100 point? Yeah, the score 100 point. Okay, that will be A, right? That will be A. So it's a 1 over 40. If we want a number, that will be 0.025, right? Yeah. Okay, this is 100. Very small probability. But yeah, 100 is not so easy to have it, right? This is 1, and we have A and B, right? We have A and B. We need A and B. We need A and B. Okay. Then the second one, we want the probability of A. A is what? A is the probability of the score equal to 90, 91 until 100. Right? Is it this one? So totally we have 11, right? Totally 11 numbers, and each number is this one. Is this probability? This is for t larger than 80. and this is for t smaller than 80, smaller than or equal to 80, right? Okay, so this one, each one is 140, right? We have 11, so we have this one. This is the result. What is this number? We need some calculus. I just leave it here. Okay, 11 or maybe like 11 times 0.025. So this is a it's a 0.275, right? 22%, 27%. Okay, not so bad. And 3, we want to find the p field. Okay, this is another side. What is the field? Field means the t were smaller than 60, right? Smaller than 60. So here we have t equal to 51, 52 until 60. So how many point? No, 60. Smaller than 60. So 59. So this is totally, the amount is 1 to 9. It's 9 point, right? 9 point. So this probability will be 9 times which one? Times the times this score, right? 1 over 60. 1 over 60. Okay, this one I divide by 3. So 3 times 1 over 20 is 0.150. Oh, so it seems like this is not small probability. That guy has a chance to get field 15% to get field. All right, then fourth. What is fourth question? Is the probability of A or B? Okay, so these are the good scores. So what is the probability of these? So what is A and B? That is t from 80, 81 until 100, right? Until 100. But we know we have separate. This is we have 80. Yeah, over 80 is this one. Over 80 is this one. So we can totally we have 80 to 100 is 21, right? 21. 0 to 9, 0 to 9, and one more. Yeah, 21. We have amount is 21. So this probability is 21 times that 1 over 40. Oh, it's a big chance, eh? This is 21 over 4. So it's 4, 20, and 2, 5, right? Yeah. Okay. So this is a 525. 525. Yeah. This is A or B. And 4 is 6. 5. The probability of t is smaller than 90. So it is not A, right? This is not A. Well, we can use the previous result. This is a p of not A. Then we have 0, right? Remember we have 0. 1 minus p of A. Some 0. I forgot which one. You can check the previous notes or can check the textbook. We have this. 1 minus probability of A, so it is 1 minus these, 1 minus 0.275, which is a 0.725. Alright. Okay. Then similar. The sixth one, P, C or better. C or better. C or better, that means P where have the T will be larger than or equal to 70, right? And larger than or equal to 70. Okay, so that means T were equal to 70, 71 until 79, then 80 until 100. So actually we have two parts. This part totally we have 10 of probabilities B, and these we have 21 the probability is A. A is 140. B is 160. Right. So then the probability will be 10 times 1 over 60 and 21 times 1 over 40. So what is this? Okay, can I leave it here? Anyone has a calculator, you can try some point. Alright, some point. And then 7s, that means pass. So pass is the probability of t larger than or equal to 60. We can do similar calculation, but now just start from 60 to 79. 60 to 79. So this is we have 10 more. So it's 20 of these. This is 20 of 1 over 60, and the other side is still 21 times 1 over 40. Okay. So this will be the answer of all these probabilities. All right. Any question? If you have any question, you can go to the office hour, and also you can leave your problem in the piazza. Then when I see them, I will give you an answer. All right. Okay. Now let's check another example. I have two examples here. Example 2. Like this. Okay, we try to solve it. Similar thing, we need 3 steps. The first step, try to make it clear what is the sample space. We give a full description of the sample space. And the second step, we need to make sure the probability for that sample space, right? Totally 100%. Then you need to distribute this 100% to different samples. Then third step, to find the final answer, right? We have 6 problems, six values we want to have. Okay, so here let us see what is a sample space, what is a experiment firstly. So this is for the phone call, and we separate the phone call as voice call or kind of data call, digital call. And another way is we separate it as long or short. Okay, so totally we have 2 different ways. One is depending on how to call it, call for just speak or for date, and the other is how long it is. So people usually you have two factors, right? One is the duration, one is the way to call. So we can put like this. We have call as a voice call or digital call, right? And this side is a long call or a short call, brief call. And then, okay, so the sample space here, right? This is S. Sample is here. We have VL, VB, we have DL, we have DB. So now we have the sample space as sample space is this one, S equal to VL, VB, DL, DB. So we have 4 elements in the sample space. And okay, this is the first step. We are done. Now we are very clearly know what is the sample space. And then we go to second step. We try to make sure the distribution of the probability. Totally 100%. With 100%, we need to distribute those 100 to these 4 places, right? Each one, what is the probability? So we can use the same graph, same table, for the similar with these. So we have L and B, long and brief, V and D, voice and date. And here's a we say the probability. Now it's a probability. We need to put the value here. And okay, now we will check what kind of number we already have. Based on the data collection by phone company, we use the following probability model. Okay, first one is PV is 0.7. So what is PV? PV is a probability of V. So you need to put it here. This is PV, 0.7. This is a marginal probability, right? It's, if we look at it in this joint way, this is a 0.7. So V has a probability of 0.7. And the second one is a PL equal to 0.6. L is here. PL is here. 0.6. Exactly? Yeah. PV include both VL and VB. Okay. And L include both VL and DL. VL, DL. Yeah. And then we have the third number, PVL equal to 0.35. PVL, okay, we have this 0.35. Alright. And any more? No. So we know these three numbers. But we want the whole description of the probability, right? We want to know all the 100% how to distribute. So here we need find more numbers according to the given number. Okay, so first one is here. We have a lot of way to do it. Like first one, I try this. I can also try this. The principle is these two numbers, these two probability do summation will be 0.5. And this is according, we have axiom, right? We have axiom. We have P and 0 also. You have two events, then the probability is the summation of each, right? We have this. Actually, suppose A and B, the intersection is empty. In this case, right? So, okay, now this one plus this one, right? This is 0.35, this one. Do summation, you will have 0.6. So here should be 0.25, right? 0.25. So you do summation, you will have 0.6. And similar, here, you do summation, you will have 0.35. Alright, then now we have the last one. What is the last one? The whole totally should be 100%, right? You do summation, here should be 1. How to make 1? This is 0.7. So this is 0.05, right? This one plus this one is 7. And this one is 2.5. I need a 3, right? This is 7. This I need 3. This is 70. I need 30. Okay, so I get this one. Alright, we are done. And actually we can have more. We can give the marginal distribution here. This is summation, I have 0.3. This summation, I have 0.4. And then we double check. These two do summation, I have 100%, right? And these two do summation, also 100%. Okay, you are good. If I just say if here these two do summation, you have number it is not 1, then something wrong. If these two do summation, these two should be 1. These two do summation also should be 1. If this is not 1, then something wrong. And also all these numbers, this should be positive. If you find any number they are negative, then something wrong. Alright, okay, so we finish step 2. Now we can go to step 3, right? Because we have full description of the distribution of the probability. Now we can check the number, which number or the value of those numbers. The first one, The probability of DL, okay, we already have it. It's 0.25, right? 0.25. Secondly, probability of D union with L. Yeah, I type U for the union. U for union. Yeah, it makes sense, right? It's not exactly U, but I use U for the union. This is letter U, capital letter U. D and L. D is here. So D is this part, right? D is this part. I put here. This is a D. This is L. So D is this part, and L is this part. So the union is what? These three, right? These three. So the probability of D union L is these three numbers. You do summation. So it's 0.35 plus 0.25 plus 0.05, which is a 0.325, right? 5 and okay, 6. One more, 6, 5. One more 5 here. Okay, so this is the probability, second probability, right? And the third problem, the probability of VB. Okay, we already have it. VB, right? VB, this one is 0.35. Oh, here, this VB, it is also a V intersection with B. You can just type VB for V intersection with B, because this intersection, no way to type it, right? Normally you look at your keyboard, no intersection for it. So people like you just put these two together. That means the intersection of these two, right? V is here, this line, and the B is here. So V intersection with B, it is just VB, right? Yeah. All right, this is the third one. Then the fourth, this is a probability of V union L. So V union with L. Yeah, I use a graph here. V is here. Right, this is V. And L is here. So the union is these three, right? These three. So we do summation. This is 0.35 plus 0.35 plus 0.25, which is 0.95. 795, right? So this is the fourth. All right, then next one. This is a 4. I still need this. These. Yeah, I need these. Right, I need these. This is a okay. Then I already finished which one? 4 done. Then go to 5, the fifth number. Probability of V union D. V union D. So we still have look. V is here, and the D. Oh, D is here. Then that will be R, right? So you don't need to calculate. You know, V union with D, that's R. The sample space. This is whole sample space. So probably must be 1. If you are not so sure, you double check. You do summation. If the summation is not 1, then something wrong. You need to go back to check what's the problem. All right. Then 6. P L B. LB. Okay, with L or similar. This is L, this is B. So this is also sample space, right? The whole sample space, that's 1. All right, we are done. We find all the values. Right? Yeah. Okay, now we finish the things we want to have. Now we check another concept. We call it it's a conditional probability. This is another section. New section. You check the textbook. Section 1.65. I forgot. This is a conditional probability. Probability. So the definition is like this. In a, you do an experiment, right? Random experiment, then you have result. Now we suppose some event, we make sure that event already happened. Under that condition, what will be the probability? So for experiment, random experiment with sample space S, suppose event B happen. B is the event, is subset of S. Then under this condition, the probability of an arbitrary event, of an event A is P A under condition B. This is a notation. This probability under condition B happen. It is P A intersection with B over probability of B. So it is this one, probability with B as a condition. You can imagine, for example, you consider your dice. Dice will have 6. Okay, we'll try. I use the example. We roll a dice. Then we can get a number. Get a number from 1 to 6, right? Then suppose B equal to odd, for example, 1, 3, 5. Then A equal to 1, 2, 3. A is kind of small. Then what is the probability of A on the condition B? Yeah, you can know the number, right? We know B is happen. If we write in this way, we know B is happen. Suppose like you have a dice. Oh, I forgot where I put my dice. I have my dice. Anyway, you suppose you have a dice. Then okay, someone look at it and told you, okay, the dice here. I see. Oh no, I know it is a odd number. Then you guess what it is. You guess whether A will happen. Then the A happen. The chance of A happen is what? Depending those 1 and 3, right? No 2. We can't have 2. Just 1 and 3. So actually, this is a 2 out of 3, right? 2 out of 3. We have totally B. We have 3 possible values, and A we have 2 of them. 2 of these numbers is part of A. Actually, this is the probability of A intersection with B over probability of B. Yeah, this is the meaning. I put it here. This is meaning 2 over 3, and we calculate depending on the definition. the intersection of A and B is 1 and 3. So this is 2 numbers, right? 2 out of 6. Yeah, it's just a fair one. It's a fair dice. So each number is 1/6 probability. I have 2 numbers, A intersection with B. A intersection with B, we only have 1 and 3, right? And numerator is totally B is 3 out of 6. So the answer is 2/3, right? 2/3. The meaning is quite simple. Now you consider, because B is a condition you already have, so you can think B is a new sample space, right? A new sample space, the conditional sample space. And then under this sample space, you check what is the probability of A. So this is a conditional probability. Conditional probability. And we also have the properties similar with the axioms. We have the axioms, right? Oh, let me turn off these. Sorry. Yeah, we only need this one. We have axioms. We have 3 axioms, right? Now we have similar thing. The first one, the probability of A on the condition B must be a number positive or 0. No negative possibles, right? And the largest one, the whole sample space, this is 1. This is 1. Right? Actually, you know what? This one in the conditional case, the things like this. This is sample space. This is A. This is a B. And if I have any like another event K, another event E is larger than B, I mean, if E larger than B contain B, then we have the probability of E on the condition B, there will be 1. Make sense? If E is or E like this, another E, yeah. So any event larger than B, the probability is 1. Right. All right. And the third one, we also have the intersection A1 union A2 on the condition B equal to the probability of A1 on the condition B plus probability of A2 on the condition B plus and so on. Here, suppose if A1 intersection A2 intersection with B is empty, it's IJ for I do not equal to J. You pick any 2, A1 A2 or A1 A4 or A2 A6, whatever. You pick any 2 different A. If their intersection with B is empty, then we have these. Alright, similar with the normal case. Normal case, we do not have this B. You remove all these B's, then you have the axiom. Right? Or you replace B with S, then you also have axioms. Yeah, because condition S is things like no S. I put it here. Probability of A on the condition S. This is just the probability of A. S happened. Now people told you, okay, I know S happened. What that mean? That means nothing, right? Equal to nothing. No information. You cannot have more information. S happened, of course something happened, right? Yeah. So condition S, that means just this one, same thing. Alright. Okay, so this is a definition for the conditional probability. Conditional probability. And then we have a concept related with the conditional probability. Independent events. Independent events. For events A, B, both are the subset of sample space S. If probability of A on the condition B is same with the probability of A, then A, B are independent. Make sense? So the probability of A, do you have B? Doesn't matter. Do you have B as a condition? Doesn't matter. You have B as a condition, you have a probability. You have another, you have the case no B, no condition. You have another probability. Now these two are same. So we call these A and B are independent. They are independent. They do not make any change, right? You have B happen or not, do not have any change on the A. You B happen, doesn't matter. B happen or not, doesn't matter. Probably A will be same. Okay, so this is definition, and we can have an example. Let me see. Example. I want. Okay, now suppose I do an experiment like this. Roll dice 2 times. 2 times. Then we have the result will be like I and J, right? The first is I, second is J. The sample space will be all of these, where both I and J, they are numbers between 1 and 6, right? So this is sample space. And we consider 2 events. I say that A equal to the summation. I have 2 numbers, right? I have suppose the summation is 7, and B equal to the first one is 3. Okay, we have 2 events, right? 2 events. The first event we check the summation of them, they are 7. Second, we say I is 3. Then we want to know the probability. We want to know the probability A, probability of B, probability of A on the B. Find these. Then question: are A and B independent? Are they independent? Do they? This is independent. Independent is oh no, I'm good. Sorry. A and B independent. Independent. All right. Okay. So we want to calculate these 3 probabilities. And similar with we just did in the example, we need to find the sample space firstly. Actually, we already have, right? So it's fine. We already have. And secondly, we want to know the probability distributed to these samples in sample space. Totally, each one is 1/6, right? So you put together, that will be 1/6 times 1/6. It is 136. So each probability equal to this. P of ij equal to 1 over 36. And then what is PA? Summation is 7. So we can have A is what? The I will equal to 1 to 6, while J equal to 6 to 1. Right? If I is 1, then J is 6. If I is 2, J is 5. So totally we have 6. Among these 6. And we have the probability of A is 6 times 1 over 36. So it is 1 over 6. This is the probability of A. And B, what is B? B is I equal to 3. I equal to 3, then J any of 1 to 6. Right? Okay, so we have totally I have 6. It's still 6. Then we have probability of B is also 6 of 36, 166, so it's 1/6. Okay, we have probability A, probability B. Now we want to find these. What is this? This one is probability of A intersection with B over probability of B. Right? So if you want to find this probability, you need to find intersections probability firstly. You check the intersection. So here we check A, B, the intersection. So we want what? Summation is 7, and the first one is 3, and I plus J is 7, right? Plus J is 7, and this is I is 3. So this equal to just I equal to 3 and J equal to 4. So we only have one sample, right? Just one result. So this is probability of AB is 1 over 36. Okay, now we can have the conditional probability. Conditional probability. Probability of A on the condition B, which is a probability of A intersection with B over condition B, the probability of B, and the PAB is 1 over 36, while your PB is also PB is 1/6, right? PB is also 1/6. This is 1/6. So what it is? It's 1 over 36 times 6, right? Times 6 over 1. I move this, turn around, and put it here. Okay, so it's 1/6. Alright. Now we check the independent. A and B. Whether they are independent, you check. Now, check whether they are same. We have PA equal to 1/6. This equal to PA on the B condition. Alright, so we say A and B, they are independent. They are independent. So we have example. We have two event. And 2 events are here. Okay, 2 events are here, and the independent. B, whether you have condition B, you think this is a condition. Under this condition, or do not have this condition, the probability of A is always 1 over 6. So A is independent with B. Okay, that's all for today. The next time we will consider more about the conditional probabilities. Alright, So bye bye, see you next time.